right, so we are going to today start right at the top of your lesson 4 notes, and I am going to skip around a little bit and give you just what's important on this. All right, so all the way over to 4. Again, this is a real world application of how to apply what you've been learning. So it says an engineer is designing a roller coaster for younger children and has tried to model some functions to model the height of a roller coaster during just the first 300 yards. She came up with the following function to describe what she believes would be a fun ride to start. Okay, a couple things I want you to write about this quick. First of all, what form is this in? Factors or standard? Standard, good. So this is in standard form. I know that the degree of this polynomial is 4, good. I know that the leading term is negative 3x to the 4th, and the leading coefficient is negative 3. Okay? Yeah, all that information that you already know. So your first question, a lot of these are very, very quick. Does this function describe a roller coaster that would be fun to ride? This is based on your opinion, if you like roller coasters or not. So what we're going to do is go right to the y equals of your calculator, and you're going to graph this. And again, you're just going to, based on your opinion, so we can kind of go either way with this. Is I want to see whether or not this is a fun roller coaster. Okay, so we're going to type in negative 3x to the 4th, followed by 21x cubed. And again, this is just the start of the ride. And then next is going to be a minus 48x squared. I'm sorry, this calculator gets tough to use. Minus 48x squared, and then I have plus 36x. And graph. What do you guys think? Yes or no? It looks steep, right? Okay, so let's go with a yes. So that is your little sketch there. If you want to draw that right on the paper, you can. Large hill, and then kind of goes from there. And your x values are seconds. So I am going to say yes, this is fun to ride. Again, it's a matter of opinion. I'm going to say yes. Since it ascends quickly and then goes right back down. So it would make for a good roller coaster in most people's opinion. Can you see any obvious x values from the equation where the height was equal to 0? If you go back to your picture and look at it, again, it kind of did one of these. And you had this one, you had this one, and you had this one right here. So this was 0, and then 2, and then 3. So I'm going to say yes. So we had 0 seconds, 2 seconds, and 3 seconds. All right, so identify those. We kind of just did right here. I'm going to say zeros at 0 seconds, 2 seconds, and 3 seconds. Okay, so what do these x values mean in terms of your distance from the beginning of the ride? That is how many yards you are away from the starting point. So this is your yardage away from starting point. Yardage away from starting point. Okay, and then E. Why do roller coasters always start with the largest hill first? Someone like their science and want to give me a good explanation there. Yeah. Perfect. Perfect answer. Lots of momentum at beginning. Perfect. This is going to continue on to the back. And what we're going to do is build your factor function from this. What a roller coaster is an application of how we can use the graphs in a real world setting. All right, so now it says verify your answers by factoring the polynomial. So here's your original polynomial. We are going to begin by taking out your GCF. So if you look at this, what is everything divisible by? 3. Yeah, and then when you have this negative in the front, I'm going to actually pull the negative with it. And do they all at least have an X in them? Yep. Perfect. So this one we are going to do a little GCF. I am left with X cubed. I need to get a positive 21, so that means multiply by negative 7 X squared. I need to get a negative 48, so I would multiply by 16x. And then I need to turn that into a positive 36, so I'm going to multiply by a negative 12. Okay, so your task is to factor. Now what you've been accustomed to doing is taking the inside part. And when we have 4 terms, what method is that? Grouping, right? Okay, please don't write this down. I want you to just think about this for a second. If we want to group this, wouldn't we take out x squared here? We'd be left with x minus 7. Is there any way that's going to match this? No. So you're stuck. So what you need to do is apply something different. And this is where some previous concepts that you've learned are going to come back into play. So what you can do here when factoring doesn't work is you're going to pick one of the zeros that we found from the front side of your sheet, and you're going to use synthetic division to reduce the polynomial into something you can work with. So from the other side, if I remember correctly, we had a 0 at 3, right? 3 seconds. Okay, so I'm going to pick that one just because it doesn't matter which one you pick. So I'm going to come off to the side here, and we had a 0 at 3. So I'm going to do synthetic division to be able to work with this polynomial further. Again, you could have picked any of them. I just remembered the 3 for sure. So I'm going to take this cubic right here and pull off all the coefficients. So I have 1, negative 7, 16, negative 12. Because I don't need any placeholders for this one. 16 and negative 12. And you're going to expect this to work out evenly because we already verified that this was a 0. So do you guys remember how to do it? First number straight down. And then what do I do with the 1 and the 3? Multiply, good. And then add straight down so I get negative 4. You're going to do it again. So 3 times negative 4 is negative 12. Add straight down and I get 4. Do it once more. 4 times 3 is 12. Does it work? It does. So here's my constant. Here's my x. And here's my x squared. I'm going to go slow through this part because this part's a little bit tricky and it makes some connections to old material. So you know that we are left right now with x squared minus the 4x plus the 4. And what you want to make sure that you don't forget is we took that GCF out. So I'm going to place that in the front. And you need one more item here. I want you to think back to the chart that you just did for homework. And when I have a 0 of 3, what do I do with the sign? Switch it. This is just like questions 4 and 5 that you guys had a little bit of difficulty with for homework. Okay, so just like that concept we discussed. So now you're almost done. The point of your synthetic was to be able to take your polynomial and reduce it down to something you can work with. So now if I look inside the parentheses, can I factor this? Yeah, it's just a trinomial now. So you essentially got yourself over that hurdle, and now you can continue. So I'm going to rewrite the negative 3x. and the x minus 3. And I'm going to factor this trinomial, multiplies to 4, adds to negative 4, into x minus 2 and x minus 2. Almost done. So I need to write this as a formal polynomial. I'll just come right over here. And then lastly, we're going to verify our answers. So P of x is equal to negative 3x, and then x minus 3, and then x minus 2 squared. Okay, so it says verified. So this right here represents factored form now. So this is your factored form. And then I take it one step further and t-chart it. So if I t-chart these, did they match my original answers? So I would have negative 3x equals 0. Divide by negative 3, so x equals 0. And that has a multiplicity. You can cross this off because we're not going to do that part. You can use all that space if you'd like to. So multiplicity of 1, meaning my graph would pass through this. My next 0 would occur at x equals 3. This also has a multiplicity of 1. So when we go to check our graph, it should also pass through right there. So we're just verifying our answers. And then my last one, I have x equals 2. This has multiplicity of 2, which means what should the roller coaster do at 2 seconds? Pass through or be tangent? Tangent. Perfect. So the last thing I do is pull up the calculator and verify these. So at 0, did I pass through? At 3, did I pass through? And at 2, am I tangent? So I'm going to take a quick look. It looks like we're good. So at 0, it passed through. At 2, it was tangent. And at 3, it passed through. So your last question regarding this problem, if you look down below, it asks you, what's wrong with this ride? So these are seconds. Do you see how abrupt this is? So in the course of less than a second, you're taking people on a roller coaster and then they're changing directions like this. So that engineer is going to want to smooth that out instead. So that's why that would be a bad model. And that's the last thing you need to state in regards to that problem. All right, so that is a little bit too abrupt. You got to be careful when you have people riding something. You don't want people to get injured. So what is wrong? Your change of direction is too abrupt. I'm going to say too abrupt, or you're welcome to put something else down. Kind of an open-ended question. Again, you're kind of leading yourself into somewhere where you may have injuries. So we don't want injured riders. We don't want injured riders. You want people to have fun, but you want them to be safe too. Okay. So how is that for an application problem? Does that make sense? So you're kind of working with your functions to build a model to represent a roller coaster. Okay. You can cross off the rest of that page if you'd like. In your packet, you are not required to do problem set 4. Okay. And I'm going to change gears and I want you to grab the loose leaf sheet of paper instead. And I want to give you a couple little quiz review questions. Just a couple. All right, so find your sheet of paper that was placed on your desk, or any old sheet of paper will do. And on the top of it, you can write quiz review. And I just want to go back and make sure we hit those concepts again so that you are prepared to do that. All right, the first thing we started your unit 3 with is your leading term test. I'm going to give you two examples, one that is standard form, one that's factored form. So your task is going to be to sketch using the leading term test. You are not graded on your artistic ability, obviously. So sketch using your leading term test. And these questions are just like the ones I'm going to ask you to do tomorrow. So if you're confident with these, then you'll do a great job. So number one, I want to say f of x equals, and let's go negative 5x to the fourth and plus 10. The more information you can list, the better. First question I'm going to ask you, what form is this written in? Standard or factored? Standard, yep, it does not have parentheses. So this is currently in standard form. There are no parentheses. So I'm going to go through my criteria. First of all, which one is my leading term? You can abbreviate it, that's fine. Yep, she's right. Negative 5x to the fourth, perfect. And then next, I'm going to state what is my leading coefficient? Negative 5, good. So it is a negative number. Next, I want you to state the degree. So what's the degree on this one? 4. So the classification is a quartic. Very good. Don't worry about your spelling. And then the last thing we do is draw the picture. So I have even degree, negative leading coefficient. So this looks like one of these. Opens down. Something like that. So that one's all set. How do we feel there? Easy? Okay, so number 2, same directions, different problem. So for this one, I want to go. I'll use f of x again. F of x equals, and let's go 2x and x plus 2 and x minus 3. Okay. What form is this one in instead? Good. This one is in factored form, which means your procedure is a little bit different. So what I'm going to start with instead, because it's not multiplied out, is the degree. So you don't need to state leading term, leading coefficient. You don't need to multiply it out unless you want to. How do I find degree when I'm in factored form? It's different. Absolutely. Yep. Add the multiplicities. So this would be a 1, this would be a 1, and this would also be a 1. So my degree is 1 plus 1 plus 1, which is equal to degree 3. So this polynomial is called the cubic. And then the last thing we need to do is figure out how it opens. So we would need to figure out, you don't have to multiply it through, but if you pretended you did, what's the leading term start, positive or negative? Well, what do you guys think? Do we see anything negative in here for the x's? No, if you multiplied this through, this would be x squared. And then x squared times 2x would give me 2x cubed, which is positive. So that would absolutely have a positive leading coefficient. So my sketch looks like this one. Okay, so give or take. How are those two? Okay. Next concept is we found the zeros and stated the multiplicities. So here's your next one. I'm going to say determine zeros, state multiplicities. So I'll abbreviate. Determine zeros, multiplicities, and whether they pass through or are tangent. Hold on. You can abbreviate. So determine your zeros, your multiplicities, and whether these pass through or are tangent. And then one of these on these two. For pass, I'm going to use a P, and then for tangent, I'm going to just do a T. And you can do the same thing. So let's say we have this one. So I want to go f of x equal to x cubed, and then x minus 2 squared, and then x plus 1 squared. Whenever you look at these, you want to think, what form is it in? So what form is this one in? Has parentheses. Good. So this one's factored already for you. When it is already factored to find the zeros, what am I allowed to go to? Right to the T-chart. Very good. So this one's the fast type. So factored means you go directly to your T-chart. So I have x equals 0 because I ignore the exponent, and I save it for the multiplicity. So x equals 0, multiplicity of 3, which means that is odd, and this one is going to pass through. Now I go over to the other one, and I'm going to say x equals 2, switch the sign, multiplicity of 2, which is even. So this one is going to be tangent. You can abbreviate whatever you'd like. Tomorrow, I think I just had you circle a P and a T. And then I'm going to flip my sign again, and I'm going to get x equals -1. Multiplicity of 2, which is an even number. Therefore, that's another case that's tangent. Do we feel okay on 3? Okay. So your last 2. Number 4, tell me what I changed on this. So I want to go f of x equal to x cubed plus 2x squared minus 8x. What's different? Standard form. Yep. This is when you have to factor it first. You can't go to the T-chart. So I deliberately gave you 2 that are opposite so you can practice that. Standard form means you need to factor first. Whenever I factor, I think, do I have a GCF? So in this case, do we? Yes, x. So x, and then I'm left with x squared plus 2x minus 8. And you're going to take that trinomial one further step. Multiplies to -8, adds to 2 would be x plus 4. And x minus 2. And now you will notice it looks just like number 3. So you conclude with the T-chart. I have x equals 0. Multiplicity 1 passes through. I have x equals -4. Multiplicity of 1 passes through. And then last, I have x equals +2, flip your sign. Multiplicity of 1 passes through. Okay. How are 3 and 4? We're going to know the difference. Perfect. Here's your last problem, okay? And your only form of homework tonight is to just study these 5 questions. 5 is going to be write the polynomial, just like homework questions 4 and 5 that were, again, initially gave you a little bit of difficulty. So let's make sure we've got that under control. So you are going to write a polynomial and factor it in standard form. Write a polynomial in factored and standard form. So in factored and standard form, abbreviate whatever you'd like. These are your notes. With zeros of, with a 0 of -1 And I'm going to say multiplicity of 2. 1 with a multiplicity of 1. And 0 with a multiplicity of 1. Just like your homework. First thing I do is take all the signs and switch. Multiplicity becomes your exponent. So I have P of x equals, switch your sign, x plus 1 to the power of 2. I take the positive 1, switch my sign. So x minus 1 to the power of 1. And then 0. You can just write x if you want. So that's one way you can leave your factored answer. To me, that looks strange. So I'm going to rearrange this slightly. So P of x is equal to, I'm going to put the x in the front. This one I'm going to write out twice because we do need to multiply it. And then minus 1. Okay. So last, to get this in the standard form, I have to multiply. So let's do these up. I'm going to go x times x, which is x squared. Minus 1 plus 1 cancels. 1 times negative 1 is minus 1. So that's taken care of. X times x is x squared. And x times 1 is x. I'm almost done. I multiply out one more time. So I go x squared times x squared, which is x to the 4th. X squared times negative 1 is negative x squared. X times x squared is x to the 3rd. And lastly, minus x. I rearrange, and that is your last answer, which is written in standard form, highest exponent down to lowest. If you if you prefer box method on that type, you could do that as well. How do we do 5? 5 tough. Questions on any of that, guys? So to reiterate, you don't have any formal homework. What I would do is look these problems over later tonight, or sit down with a sheet of paper and redo them, and see if you can get your answers matched. Okay. So your only homework tonight is to just study those 5 questions.